Hi everyone, welcome back to Quantitative Reasoning. Today we're in section 12.2 looking at measures of central tendency. So measures of central tendency is just a fancy way of saying that we're looking for different values that can help us describe the center of a data set. And there are three that we're going to look at today, and they are the mean, median, and mode. So let's go ahead and get started. So in statistics, values that represent the average or the typical value are known as measures of central tendency because they're generally located toward the center of a distribution. Now, the mean is a very common measure of central tendency, and it's frequently called the average. And we all know how to average a group of numbers together, so that's the mean. And we're going to look at it in detail in just a few minutes. But we know that to find the mean of a data set, you add all the data values together and divide by the number of data values. So the symbol that we use in statistics to represent the sum of a group of numbers is the Greek letter capital sigma, and it looks a little bit like an English E. But it is not an E. Please do not call it that E-looking symbol. This is the Greek letter capital sigma, and it's equivalent to our letter S, and so it stands for summation, and it indicates that we're supposed to find the sum of a group of numbers. So S for sigma, S for summation. Now, like I said, we know that the way to find the mean of a data set is to sum the data items, in other words, add them all together, and then divide by the number of data items. And here is the way that formula looks in statistics. So the Greek letter capital sigma stands for sum. So the formula is that the mean equals the sum of all the data values divided by the number of data values. So sigma x represents the sum of all the data items, and n represents the number of data items. Now, instead of writing out the word mean, we typically use the symbol x bar. It's a lowercase x with a bar over it, and that stands for the mean of a sample. If the numbers that we are averaging represent a population, then we use the Greek letter mu. This Greek letter, it looks like a U with a tail on the front. It's actually pronounced mu, and so this is used to represent the mean of a population, and this X bar symbol is used to represent the mean of a sample. Now, they're both calculated using this formula, but it just depends on whether our numbers represent a sample or represent the population as to which symbol we use. Okay, so let's look at example 1 together. And this says the bar graph shows the price of a movie ticket for 9 selected years from 1980 through 2019. Find the mean price of a movie ticket for this period, round to the nearest cent. Okay, so the first thing we notice is that we're only finding the mean for 9 selected years, not all of the years. So these 9 selected years represent a sample of the population, and that means that we will need to use the symbol X bar to represent this mean. Now, we know that the way to calculate the mean of a data set is to sum all of the data values and divide by the number of data values. So let's pull our data values off of the graph here, and we will add those all together. So you can use your calculator for this. We're doing 2.69 plus 3.55 plus 4.23 plus all the rest. You can see them there. And then we will get a total for that. And that total is 52.10. That number represents the sum of all the data values. So that is our sigma x. And then remember that n represents the number of data values, and there are 9 data values here, so n is 9. So now let's go back to our formula. So x bar is going to be the sum of all the data values, which we know is 52.10, divided by the number of data values, which we know is 9. And calculating that, we get approximately 5.79. So I've already rounded to 2 decimal places here because that was the instruction they gave us in the problem. And now if you compare 5.79 to our data values, you can see that it is somewhere in the middle. There are several values less than that, and there are several values more than that. And so this does seem like it represents the center of the data. Now I know that sometimes when you are typing a list of numbers into your calculator, if you mess one up, it's sometimes hard to know exactly where you were when you messed up. And sometimes when the list is really long, like it is here, you want to be able to check that you've typed everything in correctly when you get your total. So let me show you how to use your calculator's statistical function to do this. So believe it or not, this calculator actually will find the mean for you if you just know how to enter the list of data values. So the way to do that is with this statistical function right here. You see on this button labeled data, the second function is stat. So we want to hit second stat to get into what's called stat mode. And now we're just going to be working with one variable data. So it's not like we've got an XY pair. We've just got a list of data values. Each data value is just one number. So with the one var underline, hit equal or enter. Okay, now you can see in the lower right corner it says we're in stat mode. So at this point we are ready to enter data. So now hit data, and they're asking us for our first data value, which is going to be this 2.69. So we'll enter 2.69, and now don't hit enter, but just hit the down arrow. And the next thing here is that they're asking us for the frequency. In other words, how many times does this data value occur? And for each of our numbers, each one just occurs once. So we'll leave the frequency at 1 and hit down arrow again. And now they're asking for the second data value. So we'll enter 3.55, down arrow, frequency of 1, just leave it alone, hit the down arrow again, and then you'll enter your third data value, and so on. Now keep in mind, if you enter one incorrectly, you can backspace to it. You can hit the delete key if you need to, and just re-enter the correct value. Then down arrow, and then our fourth value is 4.35. Now I'm just going to enter the rest of these on my own, and you enter the rest of them on your calculator, and I'll see you at the end of the list. Okay, now I've just entered my 9.16, and I know that I have 9 values in there because I see the 9 here next to my X. So that's telling me it's the 9th data value. Now check this out. If you would like to review that you entered all of these correctly, here's what you do. You could hit the up button a million times to go back up to the top of the list, but I have a better way. If you hit the down arrow one time, of course that's the frequency for the 9th value, needs to stay 1. Then if you hit it again and you don't enter anything for the next data value, then when you go past the frequency for that empty data value and hit down arrow just one more time, it brings you back to the top of the list. So let's see that again. So here I have just entered my 9th data value. If I hit the down arrow, that's the frequency for the 9th value. Hit the down arrow again. Don't enter anything for the 10th value because there's not a 10th value. And then hit down arrow 2 more times. Boom, I'm back at the top of the list. And now I can scroll through and verify that I entered all of my values correctly. So 2.69, 3.55, 4.23. Okay, so you can do that and make sure that you got them all the way you want them. When you're sure that your list is the way you want it, then what you're going to do is hit stat var. So I'll touch that. And now look at all of the things the calculator will find for us. The first thing is n, which we know is the number of values, and we know that we had 9 values, so that's good. The next thing is x bar, which is the mean of the data set, which is what we want. So we'll just right arrow over to x bar, and they're telling us that the mean of our data set is 5.79. Of course, if we round to 2 decimal places, this would round to 5.79. And now let me show you one more thing while we're looking at the statistical functions. When you are ready to go back to using the calculator in its regular mode, you'll want to exit the stat mode. So you see right here it says exit stat. So I'll hit second exit, and it asks me if I'm sure. And the reason it asks if we're sure is that as soon as we exit stat mode, it's going to erase these 9 values that we've entered. So if you just want to change a value or two, then don't exit, because then you'll have to re-enter all of them. But if you're sure that you're finished with these data, then you can go ahead and exit stat mode. So I hit yes here. Notice the stat disappears from the bottom of the screen, and I can now go back to using the calculator as normal. And if I were to enter stat mode again and go back to the data list, it's empty. See, nothing in that data list now. Now, a lot of times our data will have already been organized into a frequency distribution for us, like the one that we see here. Let's see if we can figure out how we would need to adjust our formula to find the mean of data that's already grouped in a frequency distribution. First of all, we recognize that the frequency here means that the number 30 has been repeated in our data list 3 times. So we could go ahead and write down 3 30s. And then it says that the number 33 has been repeated 4 times. And then it says that the 40 has also been repeated 4 times. And the 50 is only included in the list 1 time. So here's our original data list. And you can see that this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 separate data values. And if you started entering all 12 of these numbers in your calculator individually, I think it would not be too long before you would say, hey, wait a minute, there is an easier way to do this. Instead of entering 30 plus 30 plus 30, why don't I do 30 times 3? That's easier typing than entering 30 plus 30 plus 30. And then I know I've got 4 of these, so why don't we just put plus 33 times 4? And then we've got 4 40s, so we could say 40 times 4. And then we've only got 1 50, so we could say 50 times 1. Now we don't really have to put times 1, of course, but I just put it so that every pair of numbers has a data value and a frequency. So you can see how that is going to add up to the same total that it would if I just typed 30 plus 30 plus 30 plus 33, blah, 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 and just added all the numbers individually. Okay, so our sum is 432. And then we know that to find the mean, we take that sum and we divide by the number of data values, which we already counted, so we know it's 12. So our mean is going to be 432 divided by 12, which comes out to 36. So now that you've seen how we did the sum here, can you figure out a way to adjust the formula that would let us take advantage of the frequencies? You probably can. Notice what we ended up doing here with our little shortcut was we ended up finding the sum of every data value times its frequency. So that gives us an idea of how we can write this new formula. So we could say that the mean now is going to be the sum of every x value times its frequency. So we're finding the sum of every x times f, and then when we find that sum, we divide that still by n. So this can be our new formula that we use whenever we have data already grouped into a frequency distribution for us. Let's take a look at it in detail on the next slide. Okay, so we know that the x represents each individual data value, and we know that the f represents the frequency of that data value. And so sigma xf means we take each data value and multiply it by its frequency, and then we take each of those products and we add them all together. So the sum of all the x times f's, and then whatever that sum is, we divide by n. And we know that n represents the total number of data items, which is going to be the sum of the frequencies. So if you add all the frequencies together, that tells you how many numbers would be in your list if you wrote out all the numbers individually. So let's try it out here just looking at the table and not looking at the list of all the numbers written out individually. So the formula says that we take every data value and multiply it by its frequency, and we add all of those together. So it's going to be 30 times 3 plus 33 times 4 plus 40 times 4 plus 50 times 1, and that would just be 50. And whatever that total is, we divide it by 12. And so if you do that on your calculator, you punch in all of this on the top and then hit equal to get a total, and then divide by 12, you'll get a mean of 36. And we know that's correct because we did it on the last slide. Now let me show you how you can use the statistical function on your calculator instead of this formula to get the same answer. Okay, so let's take a look here, and you might have already figured out what I'm about to do. So of course the first thing I need to do is get into stat mode, so I hit second stat, one variable stats. Now I'm in stat mode and I'm ready to enter data, so I hit data, and our first data value is 30. But this time there's more than one 30, there are 3 30s, because remember the frequency here is 3. So when I hit down arrow, I just need to tell the calculator to count the 30 3 times. That's what the frequency is for. And then I down arrow to go to the second data value, which is 33, and down arrow again, this frequency is 4. Down arrow for the third data value, which is 40, down arrow for that frequency, which is 4, and then down arrow for the next data value, which is 50, down arrow again, and that frequency is 1, which is the default value. So now I'm ready to calculate, so I hit stat var. Notice that they're telling us that the total number of values here is 12, and we know that 3 plus 4 plus 4 plus 1 is 12. So that's reassuring right there that we counted the right number of data values. And now when we arrow over to see the mean, it is 36, just like we expected. Now here's example 2, and it says, researchers asked 151 students, how stressed have you felt in the last 2.5 weeks on a scale of 0 to 10, with 0 being not stressed at all, and 10 being as stressed as possible. The responses are shown in the table, and they've asked us to use the frequency distribution to find the mean of the stress level ratings. Now these numbers in the left column, these are the stress ratings, and these numbers in the right column are how frequently that number was reported. So I think you can probably tell that with a table of this size, it's going to be a lot more practical for us to either use our formula that's been adjusted to find the mean of a frequency distribution, or just use the calculator's statistical function. Just to give us a little extra practice with the formula, I'm going to go ahead and use the formula here. Now I've written it down here in the bottom right so that we can look at it. And remember that it says that we want to find the sum of every x times f. And once we've found the sum, we want to divide by n. Okay, so to find the sum of all the x times f's, we would do 0 times 2 plus 1 times 1 plus 2 times 3 plus 3 times 12, and just keep doing that for every pair of numbers in the table. And so this is what that calculation looks like, and when you add up all those products, you'll get a total of 975. And the next thing we need for our calculation is n. Now if they hadn't already told us that there were 151 students, then we would have to add all the frequencies together to find out the total number of students, but we do know, so we'll just go ahead and say that n is 151. And then for our formula, x bar is the sum of all the x times f's, which we know is 975, divided by the total n, which we know is 151. And so we're going to find that the mean stress level rating is 975 divided by 151, which is going to be approximately 6.5 when we round off to 1 decimal place. Now keep in mind, you definitely could have used the calculator's statistical functions for this, and so when we go to part B, that is exactly what we're going to do. So part B says, the table represents the age of maximum yearly growth for 35 boys. Use the frequency distribution to find the mean age of maximum yearly growth. And so here's our frequency distribution. We can see all of the data values in the left column and the frequency for each one of them in the right column. And this time, instead of using the formula, we're going to go straight to the calculator. Okay, so here we go. We know that in order to find the mean of this frequency distribution, we will need to get into stat mode, so second stat, one variable data, and then hit the data button, and we can start entering our data values and their frequencies. So here the data value is 10, then down arrow, frequency of 1, down arrow. Second data value is 11, down arrow, frequency for that data value is 2. And then so on. We'll just do one more, so 12, and then frequency of 5. And then I'm going to let you enter the rest of these values, and I'll go ahead and enter the rest. Okay, and I've just entered my 9th data value, which has a frequency of 1. So when I down arrow, I'll just leave that frequency at 1. And now I'm ready to calculate, so I'll just hit stat var. And at this point, if you happen to know the sum of the frequencies, if you happen to know how many data values you should have, you can just verify that that number is correct. In this case, we know that there were 35 boys included in this data set, and so 35 is correct. And then let's arrow over to see the mean. And so the mean for this data set is going to be approximately 13.8. Okay, now let's switch gears and talk about the median. So the median is the data item that is in the middle of each set of ordered data. Now the important thing here is that the data must be in order. You can't just take any old list of data and pick out the middle number. The purpose of the median is to tell you what number has the same number of data values above it as it does below it. So here's how we find the median of a group of data items. First, we need to arrange the data items in order from smallest to largest. And you know, if you have a very large group of data, sometimes a stem and leaf plot can help you quickly arrange the items in order from smallest to largest. Then, if the number of data items is odd, that's the easiest. The median is the data item in the middle of the list. But if the number of data items is even, then you'll have two numbers in the center. And in that case, the median is the mean of the two middle data items. So the bigger your data set gets, the more inconvenient it is to count and figure out which value is in the middle. So here is a little formula that can help. If you have n data items arranged in order from smallest to largest, then the median is the one that's in the n plus 1 divided by 2 position. N plus 1 divided by 2. So let's look at example 3 together, and here we are finding the median for each of these data sets. And remember that you can't find the median until the data are put in order from smallest to largest. So I'm just going to rearrange these numbers from smallest to largest. And now when I do that, you can see that we have 5 data values here, and the one in the middle is the 90. Notice there are 2 data values less than 90 and 2 data values more than 90. So 90 is the median. And now if we think about the position, I just want us to practice using that little n plus 1 divided by 2 formula so you can see how it works. There are 5 numbers in our data set, so n is 5. So n plus 1 divided by 2 would be 5 plus 1 divided by 2. That's 6 divided by 2, which is 3. And so this is telling us that the median is the third value in the list. And then 1, 2, 3, of course, that agrees with what we found just by looking at the data set ourselves. Okay, for part B, we have a little larger data set. And notice there are 10 values here. And of course 10 is an even number, so we need to take that into account when we find our median. The first thing to do is to put the data in order from smallest to largest, and since this list is a little longer, I'm going to cross values off as we go, just to make things a little easier to keep up with. So the smallest number in the list is 7, and then we've got our 13 and our 15 next, and after that we have our 25 and 28. Then the next two are 34 and 47. And then the last 3 are 59, 68, and 74. And here are all the numbers in order. And you can see that the 2 middle values are the 28 and the 34. So because there's an even number of values, there's not one clear number in the middle, but we can only have one median. So it's kind of like, in this case, there's a tie for middle position. And so the tiebreaker is that we average the 2 numbers together. So neither of these numbers is actually the median, but instead the average of these 2 numbers is the median. So we will say 28 plus 34 divided by 2, and that's going to give us a median of 31. Now notice that 31 would come right here in between 28 and 34. So there would be 5 numbers that are less than the median, and also 5 numbers that are more than the median. And so, again, the median has the same number of values that are less than as it does values that are more than. If we think about our little position formula, we know that n is 10, so n plus 1 divided by 2 would give us 11 divided by 2, which is 5.5. So whenever you get a decimal from this little n plus 1 divided by 2 formula, it's telling you that your median is going to be the average of the number that's in the position just before this number and the number in the position afterward. So for us, that means the number in the 5th position and also the 6th position, and that's exactly what we did here when we calculated the median. This is the 5th number and this is the 6th. Now let's look at example 4 together. So it says the table gives the mean number of hours and minutes per day spent sleeping and eating in 18 select countries. So we have 2 sets of data here, the time spent sleeping and the time spent eating, and this is a sample of countries in the world because of course there are more than 18 countries in the world. Now there are 2 things different about this problem than the previous examples we've done where we found the median. One is that our data set is much larger here. You can see we have 18 items in each data set. And the other thing is that our data is not just simply a number, but it's actually a time. So there are hours and minutes involved. And I don't want that to put you off at all because as we're going to see, that really is not going to make a lot of difference to us. So in part A, they asked us to find the median number of hours and minutes per day spent sleeping for these countries. Okay, so here is the data set for the time spent sleeping in each country. And if you'll look closely at the data, you can see that they are already in order from smallest to largest if we start at the bottom of the list. So this data value is 7 hours and 49 minutes, this one is 7 hours and 50 minutes, and so on. And you can see that they're all in order. So now to find the median, all we need to do is figure out which 2 values are in the middle because we do have an even number of data values. So we want to figure out which 2 values are in the middle using our little position formula, which was n plus 1 divided by 2. Now since there are 18 countries, n is 18, so 18 plus 1 divided by 2 is of course 19 divided by 2, which is 9.5. And that means that the median will be the average of the 9th and 10th values. So now if I count from the bottom up and find the 9th and 10th values, they are these 2 right here for Belgium and Finland. Now keep in mind that I could have started at the top of the list. The middle 2 numbers are the middle 2 numbers no matter which end of the list you start at. I just started from the bottom because those are the small numbers. But now we need to find the average of these 2 values. And you may be able to do it by common sense. For example here, if we know that the Belgium number is 8 hours and 25 minutes and the Finland number is 8 hours and 27 minutes, well, the average of those 2 is just the time that's halfway in between both of those. So just by common sense, that's going to be 8 hours and 26 minutes. And that's perfectly valid when that way works for you. But if common sense wasn't so obvious and you really did need to average these 2 numbers together, this is what I would say. Notice that both of them have 8 hours. So the 8 is really not affecting the average. In that case, we would just need to find the average of the 25 minutes and the 27 minutes. So add those 2 numbers of minutes together and divide by 2, and you do get 26. So the median time spent sleeping for these 18 countries is 8 hours and 26 minutes. Now in part B, they've asked us to find the median number of hours and minutes per day spent eating for these countries. And as you can see, the data set for the time spent eating is in this rightmost column. Now, unfortunately for us, these data, you'll notice, are not in order from smallest to largest. For example, here at the top of the list, we've got 2 hours and 15 minutes, but if we go down one, we've got 1 hour and 14 minutes, but the time below that, the 1 hour and 46 minutes, would be between these two if the data were in order. And so these data, when you look at them, they're not in order at all. So if we're going to find the median, we are going to have to put these data in order. Now, you could do this really any way you want to. You can do it by trial and error. You could just write the numbers down and keep rearranging them until you get them in order. I think that would be a little bit of a time-consuming process with a data set this large. I think you can see that if it were a smaller data set, like maybe 5 or 7 numbers, it would not be any trouble for us to put the numbers in order. But the bigger the data set gets, the bigger of a job that becomes. So what I'm going to do is use a stem and leaf plot to help me put the numbers in order. Now, you don't have to use a stem and leaf plot. The only thing you have to do is get the numbers in order. But I think a stem and leaf plot will be a really helpful tool to help us get that done. So what I'm going to do here is I want you to notice that every data value contains 3 digits. So what we'll do is the first 2 digits will be used as our stems, and the last digit in each data value will be used as the leaf. So here I've got my vertical bar that's going to separate the stems from the leaves. And let's look through this list and find our smallest stem. So I've got 1, 1 here. That looks like the smallest so far. And here's 1, 0. Okay, I believe 1, 0 is going to have to be the smallest stem. So I've put that here. Now the biggest stem that I see is this 2, 1. And if we look through the list carefully, I don't see any data values where the first 2 digits are bigger than 2, 1. So I'll just list all the stems between 1, 0 and 2, 1. Okay, now let's just go through the list one value at a time and put each leaf on the proper line. So this first value here, that's 2 hours and 15 minutes, the stem would be 2, 1 and the leaf would be 5. So over here on my stem and leaf plot, I've put a 5 there. I know that this represents 2 hours and 15 minutes. Which is that first data value. So now I can cross that off the list. The next one is 1 hour and 14 minutes. So I come to the 1, 1 stem, and I'm going to put a leaf there of 4 and cross that off the list. And then we can do the next data value, which is 1 hour and 46 minutes. So of course 1, 4 is the stem, and 6 is the leaf. So we'll put the 6 right here on this line. So this represents 146, and then let's do one more together. So the next value is 2 hours and 10 minutes. So back to the 2, 1 stem, the leaf here would be 0, so I need to put a 0 right there to represent 2 hours and 10 minutes. And now I'll cross that 4th value off the list. And I think you're probably getting the idea of how I'm building the stem and leaf plot, so I'll let you finish listing all of the values. And when we've got all 18 values listed on our stem and leaf plot, we'll catch back up and see what to do next. Okay, now here is my stem and leaf plot with all 18 values listed, but of course it's not complete because the leaves are not yet in order. And remember, the whole purpose of using the stem and leaf plot was to help us get the data in order from smallest to largest. So what I need to do at this point is just on each row, I need to put the leaves in order. So this 9 represents 1 hour and 9 minutes. This 6 represents 1 hour and 6 minutes. So of course they're out of order, so I'm just going to erase these and put them in order. So they should be in the order 6, 9. And then on the next row, we've got 1 hour and 14 minutes. On the next row, we've got all of our 1 hour and 20-something minute values. And of course, these leaves are not in order. So they should be in the order 1, 2, 5, 9, 9. So let me just erase these leaves and then write them in order. Now on the 1 hour and 30-something line, the leaves are already in order. They just happen to come that way. On the 1 hour and 40-minute line, they're out of order. So I'm going to rearrange them so that they say 5, 6, 9. Then on the 1 hour and 50-minute line, those are in order. The 2 hour and 10-minute line, these are out of order. So it needs to be the 0 first and then the 5. So now if you were to read these top to bottom, left to right, you would get the times in order. This is 1 hour and 6 minutes, 1 hour and 9 minutes, 1 hour and 14 minutes, 1 hour and 21 minutes, 1 hour and 22 minutes, and so on. So you can see that they're in order now. And so now at this point, we're ready to find the median. We already know that the median is going to be the average of the 9th and 10th values, but let's just remember how we know that it's the 9th and the 10th. We used that little position formula, n plus 1 divided by 2. 18 data values means that n plus 1 divided by 2 is going to be 9.5, and that's just telling us that the median is the average of the 9th and 10th values. So let's just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the two values that are in the 9th and 10th position just happen to be the same. They are both 1 hour and 34 minutes. And so lucky us, we don't even have to average these two numbers because their average will be 1 hour and 34 minutes. So the median time spent eating for these 18 countries is 1 hour and 34 minutes. Now let's look at example 5 together. And it says the frequency distribution for the stress level ratings of 151 students is repeated below using a horizontal format. Find the median stress level rating. So I believe we used this same data in a previous example and we found the mean of this frequency distribution. But now they've asked us to find the median of this frequency distribution. Okay, I don't know about you, but I am not up for writing out all 151 values. We would have to write down 0, 0, 1, 2, 2, 2, because there are 3 of those, 3, 3, 3, 3, 3, and we would have to put the 3 down 12 times, and then we would have to put the 4 down 16 times. It's just too much, right? And it's not necessary, because all we really need to do to find the median is to figure out which position the median is in, and then we'll know which value the median is. So if we use our little position formula, n plus 1 divided by 2, and we know that the frequencies total up to 151, n is 151. And so our formula will give us 151 plus 1 divided by 2. So that's 152 divided by 2, which is 76. So the median is in the 76th position. And now I can hear you saying, but how are we going to know which number is in the 76th position? Well, let's just write out a few values and I think you'll see it. So the first two data values would be 0, right? Because there are 2 zeros. The next data value would be a 1, and there's only one value of 1. The next 3 data values would be 2's. Okay, now check it out. 1, 2, 3, 4, 5, 6. So this last 2 is in the 6th position. And notice that 2 plus 1 plus 3 adds up to 6. So the total of our frequencies will tell us what position the last of that value is in. So for example here, we know that the last 2 occupies the 6th position because 2 plus 1 plus 3 is 6. Now we can find out the position of the last 3 by adding 12. So 6 plus 12 is 18, and that means that the last 3 is in the 18th position. Then 18 plus 16 is 34, so the last 4 is in the 34th position. Then 34 plus 18 is 52, and so the last 5 is in the 52nd position. And then 52 plus 13 is 65, so the last 6 is in the 65th position. And now remember, we're aiming for the 76th position. So now when we add 31 to our 65, we're going to find out that the last 7 is in the 96th position. Okay, well, if the last 6 was in the 65th position, that means the first 7 was in the 66th position. And so somewhere in there, we're going to run across the 76th number, and it's going to have to be a 7. So now we know that the median is 7. And that is all there is to that example. And now let's look at example 6 together. So at this point, we have 2 different values that we can use to describe the center of a data set. We have the mean and we have the median. So let's compare those two in this example. So this one says 5 employees in the assembly section of a television manufacturing company earned salaries of $29,700, $30,400, $31,500, $32,600, and $33,000 annually. The section manager has an annual salary of $105,000. And Part A says find the median annual salary for the 6 people, so the 5 workers and the section manager. Okay, we know that to find the median of a data set, we would need to put the values in order from smallest to largest. Luckily for us here, they already are in order from smallest to largest. So if you check them out, you can see that. And now, since there are 6 values in our data set, the position of the median can be found by doing 6 plus 1 divided by 2, and of course that's 3.5. So the median is the average of the numbers in the 3rd and the 4th position. So 1, 2, 3, 4 would be the average of these 2 values right here. So the median is the average of 31,500 and 32,600. And once we add those 2 numbers and divide by 2, the median of this data set is $32,050. And now let's find the mean of these 6 values. So we remember our formula for the mean of a data set, and it is the sum of all the x values divided by the number of values in the data set. So if we add these 6 values together, the sum of those 6 numbers is 262,200, and then we divide that by 6 because we had 6 values, and the mean of this data set is 43,700. So here's something that I want you to consider. The median, notice, is between the 3rd and the 4th values, so the median would be right here. The mean would be between the 5th and the 6th values. If you look at these numbers, there's nobody at the plant who makes this amount of money or anything close to it, right? This is significantly more than the 5 workers make, but it's significantly less than what the section manager makes. So the mean, although it is accurate, it doesn't really reflect any of the values in the data set. But the median really does, because the median is still right in here among the salaries of the 5 workers. And so when we look at Part C, which measure of center better describes the data, I'm going to say that the median does because it's the closest to most of the values. And so when you're working with a data set and you're trying to decide which number best describes the center of the data set, if the numbers are very spread out, like right here we have one that's much greater than the rest of them, and this would be called an outlier because it's very far away from the rest of the numbers. In a case like this, the median will usually be a better measure of center to use. But when all of the data values are fairly close together, we tend to use the mean instead of the median. So it's a choice that we have to make when we're working with data sets. Now let's switch gears and talk about the mode of a data set. So the mode, as you probably already know, is the data value that occurs most often in a data set. So it's the data value that has the highest frequency. If there's more than one data value that has the highest frequency, then each of those data values is considered a mode. So it's possible for a data set to have more than one mode. We know that when we calculate mean, there's only one number that can be the mean. There's only one number that can be the median. But when we report the mode, there can be more than one mode. On the other hand, if there's no data value that is repeated, so all the data values are different, then we can say that the data set has no mode, and that is also appropriate. Now, notice that you do not have to put the numbers in order from smallest to largest to find mode. You do with the median, but you don't with the mode. However, the bigger a data set gets, the harder it is to see what the mode is if the numbers are not in order. But if you'll put the numbers in order from smallest to largest, that way the duplicated values will be grouped together and it will make it easier for you to spot the mode. That's just a tip. So here in example 7, let's practice finding the mode for these data sets. So in part A, our data values are 7, 2, 4, 7, 8, 10. there's only one value that occurs more than once, and that would be the 7. So for this data set, the mode is 7. If we look at part B, the data values here are 2, 1, 4, 5, 3. None of the values are repeated, and so for this data set, there is no mode. For the next data set, we have 3, 3, 3, 4, 5, 5, 5, 6, 6. So there are 2 6s, but there are 3 5s, and there are 3 3s. So these two values occur at a higher frequency than the other two values. So for this data set, the modes are 3 and 5. And unlike when we were finding median, we do not average these together or anything. We just report two modes, just list both numbers. Okay, now in example 8, we are again finding the mode for each of these data sets, but this time our data values are organized into a frequency table for us. Remember that the frequency tells you how many times the value is repeated. And so for this particular data set, the stress ratings are the data values, and the numbers in the right column just tell you how many times each data value was repeated. The 0 was repeated twice. The 1 is only included once. The 2 was included 3 times, and so on. So when we think about the mode for this data set, the mode is going to be the data value that occurs with the highest frequency, and that would be the 7, because the 7 occurs 31 times, and no other stress rating occurs that many times. So the mode for this data set in part A is 7. When we look at the data set for part B, this is the age of all the United States presidents at their inauguration. So there was one president inaugurated at the age of 42, there was one president inaugurated at the age of 43, and so on down the table. Okay, so the mode will be the age that occurs the most often. In other words, it will be the age that occurs with the highest frequency. And so when we look at our frequencies, the largest frequency is 3, and so there were 3 presidents inaugurated at the age of 51. The 51 is the data value. The 3 is how many times that data value occurred. And so 51 occurred at a higher frequency than any of the other ages, and so for this data set, the mode is 51. Okay, everybody, we are almost to the end of the entire course. This is the next to last section in the course, and we have just finished that. That means you have one more section left to go, and so I'll catch you in the next video, and we'll finish up this course together. See you then. Bye-bye.